All right, here is our video lesson for Chapter 7, Lesson 6, titled Solving One-Step Inequalities. We are on the first set of examples on page 558 in your book. Now, this section is very similar to all the previous sections we've done up until now, except now we're going to do a little graphing on the number line. That's the only thing that's going to be added in. And so let me kind of break down what's been going on. Up until now, we've been solving equations to get an answer for like x, y, z, n, whatever you want to call it. We've had all these different letters, variables, and we find an answer, n equals 4, x equals 1/3. Whatever the answer was, it was always something equal to one answer. But now that we're dealing with inequalities, the process is still the same, except now you're going to have a different kind of answer. And most of this will make sense as we go through these examples in this section. Now, I want to talk about the top of this page here where they give us some rules. Here they basically say if you're dealing with inequalities, whatever you do on one side, if you're adding something to the left-hand side, you have to also add to the right-hand side to keep them balanced. Same thing if you subtract. If you do something to the left-hand side, you have to also do it to the right-hand side of the inequality, just like we did when we solved regular equations. Now, this seems pretty obvious, but you're going to see why in just a little bit, how it can affect your answer. So let's just go ahead and jump right into these examples. Our first example here is a plus 1/2 is less than 2. And I'm going to go ahead and just pull up my blank screen. You go ahead and get your scratch paper or note paper ready. And we'll go ahead and just do everything that's asked for us here. Now we are asked in this example to solve each inequality, represent the solution set, which means the answer, on the number line provided. So we're going to basically graph our answer. And you're going to see how that looks right now. First step, always rewrite your, in this case, inequality. A plus 1/2 is less than 2. Excuse me, not negative 2. I don't know where that came from. All right. A plus 1/2 is less than 2. Now, let's go ahead and figure out what's going on. Our variable is A. What's happening to it? We're adding 1/2. Well, what's the opposite or inverse of adding? We're going to subtract. So if we were adding something, we're going to subtract that same amount. But I did it on the left-hand side of my symbol, so whatever I do on the left-hand side, I have to also do on the right-hand side. Notice that I never do anything to my letter underneath, so that comes right on down right now. A. If I had a half and I spent a half or I lost a half, I have nothing left over. My symbol comes right on down, just like the equal sign did before in our other problems. And then now, if you have $2 minus $0.50, what do you have left? $1.50. So there's your answer. A is less than 1.5. Well, what does that mean? Well, that means if I plug in 1.5, well, actually, let's just do it this way. Let's just do the fraction. I have 1.5. That's my A. I'm going to add, another half. Let me get my words together here. Now let's check this out. 1/2 plus another half is 2. Is 2 smaller than itself? No. So then what's going on here? Well, here's the explanation. This says in order to have a letter in this equation and make this whole thing true, the value of this variable has to be something smaller than 1.5. So for example, what's a smaller amount than 1.5? Let's try 1. So if we plugged in a 1 for A, 1 plus half less than 2. Let's add this. 1 plus a half, well, that's 1.5. Is 1.5 smaller than 2? Yes. That means we can plug in any number we want for the letter A, provided that it is smaller than 1.5. So I can pick 1, I could pick a half, I could pick 0.1, 0.2, whatever I want. I can even pick negative numbers, because remember, negative numbers are all smaller than positive numbers. So I have an infinite number of answers. Now let's explain to you what that means. If I had a number line, and I'll draw one over here, that means, here's 0. If I had 1.5, here's 1, here's 2, so 1.5 would be right here, that any answer not equal to 1.5 or smaller will work. So I can pick any answer on my number line smaller than 1.5 into infinity, and it'll always make this statement true. Anything smaller than this plus a half will be less than 2. I understand this may be a lot to take in at first, but it will make more sense as we go into it. So please, for right now, write any questions you have on the side, and I'm hoping that I'll be able to address them as this video progresses. If not, save them for class, and we'll address them then. So let's go ahead and review this note we have on the left-hand side. It says open and close dots. When graphing inequalities, which are what these things are, an open dot is used when the value should not be included in the solution. So I kind of made a mistake here when I first graphed it. I put a solid dot to show where 1.5 was. But I corrected myself by using an open dot, because according to our answer, A is less than 1.5. That means it has to be smaller than this. It can't be equal to it. It has to be smaller, which is why we use an open dot, because it can't be equal to it. It has to be smaller. And we use, to continue our notes over here, we also use the closed dot to indicate the value is included in the solution. So whenever we have that less than equal to or greater than equal to, then you're going to have a solid dot. And believe me, there are some examples coming up that use that. So let's go ahead and continue with our next part. Our next example we're going to deal with now is example 2. Now, just like before, just like everything else we've done, treat it like a regular equation for now. So on your paper, you'll begin by rewriting the equation. Whoops, let me make that a little clearer. There we go. And we have -6 is greater than, I don't know what's going on with me right now. There we go. -6 is greater than or equal to n minus 5. If you remember, if you remember from the note up here, when we graph it, if we have any of those symbols there, we're going to be using a closed dot. So we'll remind ourselves when we get back to the end of this and graph it. For now, let's go ahead and solve. What's my variable? My variable is n. What is happening to n? N is being subtracted by 5. So what's the opposite of subtracting 5? Adding 5. I'll add 5 here, and I'll add 5 here. Working from left to right, -6 plus 5 is a -1. My symbol comes right on down, greater than or equal to. The letter n wasn't touched at all. It comes right on down. If I subtracted 5, then added 5, I'm left with nothing. So now I already have my solution. The solution to this inequality is n, which could be any number, as long as it's less than or equal to -1. So on a number line, here's what that would look like. Let's see, here's 0, 1, 2, 3 in the negative, 1, 2, 3 in the positive. So n is less than or equal to -1. So here's 0, here's -1. So I can draw a closed dot because it could be equal to -1, but now n has to be less than -1. Well, if you remember, in which direction will numbers be smaller than -1? The left or the right? If you remember correctly, with negatives, the bigger they look, the smaller they really are. So I would go to the left. And this is what the graph would look like. Now, you can, of course, draw this line on the number line itself, but I like to draw it above it just so you get a better idea. So any number from -1, including -1, all the way to the left into infinity will make this statement true forever and for always. And like we said in our rule up here, because we use the equal sign on the bottom, we have a closed dot. Now, if you have any questions, please write them on the side. If you feel pretty confident, why don't you go ahead then and work on the got it here on A and B. Make a number line, graph your answer, show all your work somewhere on the side, and write your final answer here. If you want to check your work, feel free to come in the morning. If not, let's go ahead and move on to the next page. Now, in this next page, we have a different kind of example. The first two examples we dealt with all had to do with adding, subtracting. Now we have a slightly different rule for multiplying and dividing. Because of course there's always got to be a little difference. This is math class. Nothing's always the same every time. Some things change just slightly. So here's what the new rules are. Basically it's this. If you multiply something on the left-hand side, you have to multiply the right-hand side to keep it balanced. And vice versa, if you're dividing something on the left-hand side, you also have to do it on the right-hand side. But we're going to come into something a little different in some of these examples. And we're going to see that right now. So let's go ahead and look at example 3. Now, example 3 looks like your basic one-step inequality. And we're going to solve it like a basic one-step equation, except we're going to have one little change. First step is always the same. Rewrite everything nice and big. So negative 2g times, or less than 10. Now, what's our variable? It's g. What's happening to g? It's being multiplied by negative 2. So what undoes multiplication? Division. And our rules above said whatever you do to one side, if you multiply or divide, you have to do to the other. So if I divide this side by negative 2, I have to divide this side by negative 2. Well, how many times will negative 2 go into negative 2? One time. So I'm left with just 1g. How many times will 10 go be divided by negative 2? Well, let's work on our sign first. I have a 10 divided by a negative, a positive divided by a negative. That's going to give me a negative answer. 10 divided by 2 is 5. Now here's where the difference comes. Here's how you should think about it. Our answer before I did anything else up here was just a regular old positive 10, correct? Do you see that there's no symbol here which tells us that this is a positive? Well, that's good. Here's the difference. My final answer ended up being what? A negative. So this went from a positive to a negative. It changed signs. Whenever that happens, that means my symbol is going to have to change directions. So that's the new rule here. In order to solve these correctly, look at your answer from the beginning and look at your answer at the end. If the sign changed from negative to positive or positive to negative, like I have here, then your symbol in the middle, your inequality symbol, must flip direction. Now let's check why that is. This is the correct answer that we suspect, so let's check it out. If I used a number line, I would want to graph every number that is greater than, but not equal to negative 5. So here is 0, 1, 2, 3, 4. Here's negative 5. Then there's more negatives that way, and then there's some positives going this way. All right, so let's see. G is greater than negative 5. Does that say equal? No, it does not. So we know we're going to have an open circle because it's not equal to negative 5. In which direction do all numbers get bigger than negative 5? Everything over here. So I'm going to go ahead and just pick a number to check my work. I'm going to go ahead and pick the number 0 because it's on this line. It's right there. So it should work. Let's check it out. What is negative 2 times 0 compared to 10? Well, negative 2 times 0 is 0. And is 0 less than 10? Yes. So I know that my line's facing the right way. But let's say you didn't change your line. Let's say you still had this answer. G is less than negative 5. Well, then your graph would look like this. It would look almost similar to what we have above. 1, 2, 3, 4. Here's negative 5. Now instead, you'd have an open dot still. But if you said G is less than negative 5, that means all your answers go this way. So I'm going to pick a number way down here. And I'm going to pick, let's say, I'll pick the next number. Let's try negative 6. So let's say I plug in negative 6 into my equation because I think it's a possible right solution. Negative times a negative is a positive. 2 times 6 is 12. Is 12 less than 10? No way. So because this is not true, because it's false, I know that this symbol had to be wrong. So remember, look at your answer in the beginning. It was a positive. If it changes its sign by the end, I don't care what the number is, if the sign is changed, then your sign needs to flip. Let's go ahead and practice some more of these now. Let's go ahead and go on to example 4. As always, any questions, write them on the side, and then address me either in the morning or during class when we review. So moving on to our final example, example 4. I will go ahead and take everything out so we can have a nice clean slate to work with. All right, and let's begin again. Process always the same. Rewrite your algebraic equation. Let's talk what's going on here. Our variable is x. What's happening to it? It's being divided by 3. What's the opposite of dividing by 3? Multiplying by 3. So I'll multiply this side by 3, and I'll multiply the other side by 3. Multiplying something times a number and then dividing it by that same number cancels out, and you're left with whatever you had to begin with. In this case, that's x. I have a negative times a positive, so that's going to be a negative answer. 4 times 3 is 12. Now let's go ahead and look at our symbol. Originally, we had a negative 4. Now we have a negative 12. Did my symbol change? Negative to negative? No, it did not. So my direction does not change either. Remember to only use that rule when you're multiplying or dividing. It does not work with adding, subtracting, just multiplication and division. But like always, let's check our work. So first of all, we need to graph this. So I need to graph x, which is going to be any number that's bigger than or equal to negative 12. So I'll draw kind of a big number line. Here's 0. I'm going to go ahead and count by 3s. So that's 3, 6, negative 9, negative 12. Then negative 15 would be next, and so on and so forth. So x is greater than or equal to. That means it can be negative 12. And then since it's greater than, since x is greater than, that means everything bigger than negative 12, which means I'm going to go this way, because this is the direction things get bigger or greater. Now to check my work, I can pick any number that's in this range. So my favorite one to pick is 0. I'm going to go ahead and put, actually, since it's division of the fraction, I'm not going to use 0, I guess. I'll go ahead and pick something even bigger and just try to use maybe positive 3. So positive 3 over 3, is that greater than or equal to negative 4? Well, let's check. 3 over 3 is 1. Is 1 greater than or equal to negative 4? It's not equal, but it's definitely greater because all positives are greater than negatives. So yes, I know my arrow is going the right way. And you can pick any number you want that is bigger than or equal to negative 12, and it'll always be a true statement no matter what you get down here. That's how you check these problems. So inequalities really don't give you just one answer. They give you an infinite number of answers in a given direction, depending on a starting number. And that could be very useful depending on what the situation is. We're going to discuss some of these real-life situations in class. So for now, I need you guys to go ahead and review your notes, write down any questions you might have, and if you feel comfortable enough, then let's go ahead and work on the got it's, the C and D. Make sure to show all work. And if you want to, come by in the morning, or yeah, actually the morning would be best to come check your answers, or also we'll discuss it in class. All right? Good luck.